Hi everyone, this is Matt. I've been playing with Dask and Xarray on Cheyenne, a high-performance computer. Uh, this is mostly thinking about deployment and then a little bit of how to set up Jupyter notebooks and such. So I'm going to go through my workflow and the things that I've learned, and hopefully I'm sure this will change in the future. So I've SSH into Cheyenne. I've followed the instructions on the right. This is on the wiki of the Pangeo discussion GitHub repository, and I've set up already a con environment for me. If you follow the instructions, you'll get the same thing. So the first order of business is to launch Dask on the cluster. Currently, we're just in a login node. I have no jobs running currently, but I do want to set up some jobs. When you're setting up Dask, you need to set up both a scheduler and some workers. You can set this all up in one go. I found that when I asked for many nodes at once, the job scheduler took a long time. Because I'm really focused on interactive use, I want to get things quickly. I found that by asking for nodes one at a time, I got through the job schedule a lot more quickly. So we're going to be a little bit hacky here. So this Dask job script launches one scheduler and about 5 workers, all on one node. This secondary script, add Dask worker, doesn't add a new scheduler, it just adds 6 more workers. If you want, you can play with these numbers. You can change select to, in the script, you can change select to 10 to ask for 10 machines. You can increase the number of CPUs, etc. But splitting it up give me a more interactive feel. So I'm going to submit those. I'm going to submit one of these main jobs, and we'll see that starts up pretty quickly. So it's not queued; it's going immediately. I have 30 minutes. Hopefully, we'll be fast in that. And I'm going to submit a few of these add Dask worker jobs. Sure, IT would prefer me to do something else than this, but those get started pretty quickly. Yeah, so they're all running now. Now I need to start up a Jupyter Lab server, or Jupyter Notebook server, on the scheduler node. To do that, I've made this small script, set up JLab. I'm going to use Jupyter Lab. I prefer it. People might prefer Jupyter Notebook. They're both available. So I'm going to run this script just here in my login node. And this is going to start up Jupyter Lab remotely. And it's also going to print out a command that I can run on my laptop that will set up SSH tunneling. I need to log in as normal. I've already running this over here. Let's try this again. I'd done this earlier, and those ports were already taken. Now we're a lot better. Okay, so this lets me open up a couple windows on my home computer. So I can go to localhost 8787. This is going to give me the Dask diagnostic dashboard, which is useful to see diagnostic information. I'm also going to go to localhost 8888, and this is going to give me a Jupyter Lab server. I prefer Jupyter Lab. Jupyter Notebook is also available. I think there's a classic notebook option. So this gives me a standard notebook interface. If I want to, I can also, open up a terminal from here and do a variety of other things. But I'm not gonna do that. I'm just gonna use notebooks for now. Okay, so this notebook was generously provided by Joe Hammond, and it looks at an X-ray data set. So we're going to connect to our Dask cluster first using these lines of code. This is all also available in the wiki. And we see here that we have 29 processes with 174 total cores, about a half terabyte of memory. That's good because as I open up this data set, we see that data set has around 250 gigabytes in size. So this is just showing some information about this data set that we're reading. This is coming from somewhere on the NFS. So we can look at some of the variables that are within that, and we see that they are all arrays of various sizes. These are sizable enough that you would not want to deal with them on your laptop. And we're going to do some simple computations and plot a result. On the right, you're seeing Dask spin up and do a lot of this work. You're seeing the number of bytes that are stored on all the different machines, who's doing work, and what every core is doing over time, to give you a sense of what you're spending your time on. This purple is a lot of opening data set. So we're doing a lot of disk I/O here, and that's taking up most of our time. But we get some nice picture out. off of a decently large data set in interactive times. If we want to go a little bit faster, if we want to interact a bit more, we might want to persist some of those data sets. So by default, Dask is lazy, meaning that it won't load data in until you ask it to compute something. By default, Dask will also throw data out as quickly as possible. We can override that behavior and find some particular aspects of our computation that we want to persist in RAM. So here I'm taking out one data set from our full X-ray data set, and I'm persisting it in memory. So you notice that now my workers are holding on to around 50 gigs total, and all of that purple, all that open data set calls have already been done. Now if I compute something, so the computation we just did, that computation would be much, much faster. So I ran it around a couple of seconds. We get the same result. This is nice because I might not want to compute the range of the mean of this data set over time. I want to compute the range of the standard deviation. So I've changed this a little bit. And I can iterate more quickly now that all my data is already in RAM. So I can see I have these two images. Let's collapse a couple of cells here to get a little more space. I see that even though this region is sort of cold, in the mountain region, it's actually quite variable over time. So we can start to iterate a little bit more quickly. Okay, that's all I had to share. You can check status. Something I want to keep in mind is that our first job here only had 30 minutes. I've been thinking about maybe extending this first job to maybe a much longer wall time, and then just feeding in Dask workers over time as needed. I'll try updating the wiki with some of this information. I'll also put all of the scripts that I use inside of a gist and attach them to this YouTube video, so you should be able to download them easily. Okay, thank you for your time.